We're in Algebra 2 on this beautiful Tuesday, January 22nd. Yesterday was Martin Luther King Jr. Day. Welcome back from the 3-day weekend. All right, so today we're doing intervals and end behavior. There are two homework assignments. One of them is talking about intervals. One of them is talking about end behavior. So let's talk about both of these. Consecutive. Everyone has their participation cards still. Consecutive. What do I mean when I say consecutive? It's a mathematical term, but it's also a term that you can use in the real world. Is there a quiet raised hand out there? Fiona? In a row, yeah. One after the other. They're right next to each other. Yes, you can turn that in.
Oh my god!
I was expecting to like kind of slide it instead of like just toss it.
I expected it to go somewhere else.
I'm going to say one after the other.
I'm the healer. I decide whether you guys.
All right.
Whoa.
Fiona, you got your
She
XP.
just like tell me what to do. That should
Is everyone being negative?
yeah.
No.
All right. End behavior. Let's talk about end behavior. End behavior is at the very extremes of the x-axis. So what happens? It's answering this question. What happens to the height for the left and right parts of the graph? So this is the really big idea today, is end behavior. And this is the thing that will cause us to dance, because we will be able to graph end behavior with our bodies. So it's going to be fun. I promise. All right. We are actually dancing. We're all going to get up in a row, and then you're going to dance. And if you dance incorrectly, then you go to the back of the line. So positive and negative intervals. So I already wrote this all out for you. So this is the general way of solving all the positive and negative interval questions. So first, check if all the zeros are consecutive. Make sure it's one after the other. For example, in example 1, these are the zeros. -1, 3/4, and 5. I'm looking for the sign between -1 and 3/4. Are these two zeros here and here consecutive? Thumbs up, thumbs down. Are those two zeros consecutive? I only see two people with thumbs. -1 and 3/4. Are those consecutive or are they not consecutive? Not consecutive is thumbs down. Consecutive is thumbs up. The answer is thumbs up. They are consecutive because it goes -1, then 3/4. They're right next to each other. If I had instead asked -1 and 5, those are not consecutive because there's a 0 in between them. So they're not, or these are consecutive because it's one followed by the other, which is the definition of consecutive, one after the other. -1 and 3/4 are right next to each other. However, if I had to ask you 1 and 5, or -1 and 5, those are not consecutive. They are not next to each other. So far, so good. By the way, if they are not next to each other, for the sake of this homework assignment, and this is, if I could do a star verbally, this is your verbal star. If they are not consecutive, the answer is going to be they switch signs. I'm not going to repeat that, but that was super important. All right, so next thing is to find a nice number in between the two zeros. So if they are consecutive, which they most of the time will be, if they are consecutive, find a nice number in between the two zeros. And then substitute that nice number into each linear factor. So I'm going to do these steps on example 1. You're going to help me out, and then you're definitely going to be doing example 2 for us. Okay, so first, we already checked that -1 and 3/4 are consecutive. So check off of number 1. Yes, we've done that. Now we're on to number 2. Choose a nice number in between those two zeros. What is a nice number in between -1 and 3/4? What's a nice whole number? Easy to multiply, easy to add. What's a nice whole number, Andrea? 0 is a perfect number. Thank you, Andrea. That would be the number I would have chosen as well. 0 is a really, really good number because if I multiply by 0, hey, it's 0. If I add 0, hey, it's whatever the number was. It's a really, really nice number. So I chose my nice number. I just did step 2. I'm on to step 3 to substitute that nice number into each of these linear factors. I'm going to sub it into this one, and see if it's positive or negative. All right. So we're going to go rapid fire here. Lots of hands, lots of people will participate. When I sub 0 into my first linear factor, is it positive or negative? Quiet raised hand. Eva.
Negative.
It is not negative. Why is it positive, Eva? When I sub in 0 for x, So it's not positive, it is negative. I don't know what I'm talking about. That's a teacher error. It is negative. That is correct and a teacher error. Double XP, basically. And log it in your extra credit tracker, if you have it. This is negative because this whole term will be 0. 0 minus 3 is a negative. All right, next. When I do the second linear factor, James. It is indeed positive. Turn in your card, James. My next linear factor, Geo. It is indeed negative because 0 minus 10 is a negative. Geo, turn in your card. Thank you. And then all together, when I multiply these together, I get what? Quiet raised hand. Chris.
Positive, dude. What the heck?
Why is it a positive, Chris?
Because it just makes it a positive.
That's not a good enough answer.
The two negatives and the positive make it a positive.
Why do two negatives make a positive?
Negative times negative is positive.
Ah, that's what I'm looking for. Okay, now I believe that you know what you're talking about. All right, Chris, turn in your card if you haven't already. All right, how many cards are there still out there? I think Stego has her card. Teflon, did you already turn it in? Okay, so it's the two Stephanies that still have their cards. You two are next.
Good job.
So, what is my answer? What is the sign of F on this interval? One of the Stephanies.
Positive. Oh my god.
Stephanie got it.
Thank you.
Turn in your card, Stego. The answer.
You're laughing at me. It's hurting my feelings.
Don't hurt her feelings. She's a fragile person.
I am. I'm very sensitive.
The answer here is positive. The reason that it's positive is because all of this turned into a positive, and that is the sign on this interval. This is a huge calculus concept. I wish I had a calculus student in here to back me up on this, but we do this so often. For 2 units in a row, this is all we do. We check intervals. Finding the intervals is a little bit harder, but we check these intervals. You will be doing this in calculus, you 5 students who are taking calculus next year. So this will be very familiar next year. All right, example 2. You guys are going to do this in your own groups, and I'm going to see if you can get it correct. You're doing the same thing, checking if it's consecutive. By the way, we can do that as a class. Are these 2 zeros consecutive?
Yes.
No?
5 halves and 4, are they consecutive?
Yes.
Yes.
Yep, it goes there and there. They're right next to each other. They will always list these in order, which is really nice. But sometimes they will be out of order in real life. But on the homework set, at least, they're always in order. They're consecutive, which means you're doing step 2, you're doing step 3, you're finding an answer and checking with your groups. Go ahead and do that now. We're back. All right, so what is the nice number that you guys chose? Who still has their card? Teflon, Teflon. What's a nice number that you chose? 3. That's a good number because 5 over 2 is the same thing as 2.5. Between 2.5 and 4, I think 3 is the best possible number we can choose. You could choose 3.5, yep.
3 and 3/4.
I don't know if that would be as nice because it's a little bit harder to work with, but it is a valid number in between that interval. All right, so when I plug in 3 here, give me a thumbs up or thumbs down, positive or negative. Positive or negative for the first one? Everyone's Geo? What is that, Geo? Is that an in between? Ah, it's positive. Okay. Next linear factor is it is a positive. Next linear factor, when I plug in 3, it's going to be 3 minus 4, which is, yeah, you guys got it, negative. And then the next one is a positive, which means this entire interval from negative or from 5 halves to 4 is negative. Very nice. Yeah, you guys are solid on that. Let's go ahead and talk about the next topic, which is the dance, the end behavior.
Wait, is that all we have to do though?
That's all you have to do for the first homework assignment. That's it. We're on to the second homework assignment. So, we don't talk about Fight Club and Fight Club, but we do talk about end behavior when we're in math class. So, in math class, this is how I read this thing. Go ahead and write this in your notes. This symbol right here, you don't say arrow. Don't say arrow. Say approaches.
Wait, where is it?
At the bottom of your notes. How to talk about end behavior.
Why can't you say arrow?
Because you'll sound like a simpleton. So, this is how Mr. Sindel is going to pronounce this. As x approaches negative infinity, f of x approaches some value. I have 2 choices. It's either positive infinity or negative infinity. Although in calculus, you'll realize it could be literally anything. It could approach 5. It could approach pi. But for today's sake, you have 2 choices. Positive infinity or negative infinity. So, as I go to the left. That's what this is really saying. So this is your translation. This thing means left. This part right here, circle that left part as x approaches negative infinity. That means left. As I go left, what is the, and this thing right here means height. As I go left, what is the height? As I go left on this graph, as I go farther and farther left, what is the height? The height is either positive infinity or negative infinity. What do you guys think? Positive infinity or negative infinity as I go to the left? It is negative. It's going down here, downwards towards negative infinity as I go to the left. So the answer here is negative infinity. Write it down. All right. Everyone has already participated. Everyone has their cards in. So who can read this to me?
Got you.
Fiona.
X approaches negative infinity. And f of x approaches negative.
There it is. Thank you, Fiona.
Wait, what?
That's all I'm asking for.
Does this
All right.
have to do with what we did on the top?
No, this is brand new stuff. Brand new stuff. All right, so now I'm approaching positive infinity. Last time I was approaching negative infinity. So what does this thing mean? This thing right here means as I go
You're going to the right?
to the right. Yes, Chris. As I'm going to the right, what is the height? Again, f of x always means height.
You're going to the
What is the height as I go to the right?
up.
Up. Up means Eva?
Positive.
Positive infinity is correct. Thank you, Eva. So, while the mathematical notation is read, well, actually, let's get another participant. How do I read the mathematical notation again, Chris?
X approaches, approaches positive infinity. F of x approaches positive.
There it is. So that is the mathematical notation. But what this is really saying is, as I go to the right, the height goes towards infinity. The height goes up and up forever. So can we translate between the symbolic notation, what it really means? Does everyone really know what it means? James, do you really know what it means? Are you like a 5 out of 5 or 4 out of 5? 4 out of 5? Okay, that's good. I hope everyone is above a 3. Okay, this is where we start doing our dance. Here we go.
Oh my god.
I'm going to simplify this all down into a dance. I'm trying to make this as easy as possible, guys. Okay, so assume that you're looking at the highest degree term. Highest degree term is the one that has the biggest n. Notice that this goes n minus 1, then n minus 2. All of these things, cross them out. We don't care about them. Cross them out. We only care about the first term. We only care about the first term. And I would love to get into more depth on why we only care about the first term, but here's my 5-second summary. The first term has the biggest exponent, so it will affect the height more than any of the other terms. So, let's assume n is even. Let's assume this power is even, like 2 or 4 or 6 or 8. Who do we appreciate? So, when I assume that it's even, I'm in this left-hand column. When it's even, what do we notice about these graphs where n is even? Let's pay attention. Here we go. As x approaches negative infinity, what does the height approach? I want to get some new people in here. James, go for it. As x approaches negative infinity of this graph, what does f of x approach? Careful here. So I'm going to the left. What is the height? As I'm going to the left, the height goes towards, it is positive infinity. Write it down in our notes. Positive infinity. We'll need this table. It'll help us out a ton later. As x approaches positive infinity, Geo, f of x approaches positive infinity. Perfect. Oh my gosh, we're getting so close to the dance. I'm excited. Let's do the other even. The other even is when a is less than 0. When this first term is negative instead of positive now, then it's below the x-axis. So as x approaches negative infinity, f of x approaches, Andrea, negative infinity. There it is, Andrea. Eva, you're doing the next one. As x approaches positive infinity, f of x approaches negative infinity. As I go to the right, it goes down. Good job, Eva. All right. By the way, this is what I need you to keep in your heads. All I'm going to give you for the challenge dance is I'm going to say n is odd, a is positive. And you'll have to do a dance just based off of a and n. Just based off of n and a. Based off of those two things, you should be able to do the correct dance. Here we go. As x is negative infinity, f of x is, Fiona?
Wait, what?
As x goes towards negative infinity, this approaches negative infinity. Good job. As x approaches positive infinity, f of x approaches...
Positive infinity.
Hold on.
Was I wrong?
Teflon.
What?
As x approaches positive infinity, f of x approaches
Positive?
positive infinity. Yes. If you like doing this type of stuff, this is exactly what we deal with calculus. In calculus, it deals with infinities over and over again. As x approaches negative infinity, when a is now negative, when this first term is negative, f of x approaches, Eva? Positive infinity. It's a flip of this one. Notice that going from here to here, they flipped. This one is going to flip as well, which means as f of x, or as x approaches positive infinity, f of x approaches, James? Negative infinity. All right, come on, go. Before we do the example, I want to test you guys with a dance. So you have 4 options for the dance. There's only 4 dance moves that you need to know. Is everyone paying attention to Mr. Sindel? There are 4 dance moves. This is the first dance move. N is even, A is positive. Are you ready for the next dance move? N is even, A is positive.
What?
That's the dance move. Notice how it matches this graph. Both my arms are up. A is negative, N is even. That's this dance move. Okay, and then we'll always be in a line, so I will be facing your back. So you'll be doing it like this. N is odd, A is positive. You're gonna go like this.
Oh,
N is odd.
Oh, we're just doing the graph.
We're doing the graph.
I do that.
A is negative, N is odd. Goes like that. You guys think you can do this without using your notes?
No.
Take a look at this for another 30 seconds. We're going to do the dance without using the notes. All right, we're back. We just had a ton of fun with dancing. Our winner, who is our winner again? Eva is our grand champion. Good job, Eva. Let's answer this final question. This is the type of question you will see on Khan Academy. Sometimes they will give you a graph. The harder question does not give you a graph. In this polynomial, first answer me this. Is it a positive even, positive odd, or negative odd? Only look at the biggest term.
Oh, okay.
What is this? Quiet raised hand. Is it positive even, negative even, positive odd, negative odd? What is it? Quiet raised hand. What is it? There's only one person that knows. 2 people, 3 people, 4 people. Teflon. Positive odd? No. Gio. It is a positive even. Even because it's an even power. Positive because this number is positive. So it's a positive even. I'll go get the XP at the very end. If it's a positive even, as I go to the left, what do I go to? Positive infinity or negative infinity? As I go to the left, positive even, shout it out. Positive. So it's not B and it's not D. It needs to be a positive and a positive. As I go to the right, is it a positive or a negative for a positive even function? Positive even function. We're on this one right here. Positive even function. As I go to the right, I approach what? Positive or negative? Positive. So the correct answer is A. That concludes our notes. If you have questions, come and ask me while you're working on the homework. Why? You're wasting ink. All right, go ahead and write your summary, and then you can work on Khan Academy.